Well, hello everyone, and welcome back to Adrian's Digital Basement. Well, this is part 3, the final part of the TRS-80 CoCo repack series. As is usual for my multi-part videos, this is a continuation of part 2, so I really recommend you watch that, and of course part 1 before that if you haven't already, to know what this machine is all about. As you can see, the machine is a little bit cleaner and it's back together here on the bench, but we're going to go back in time to when I was working on repairing the CoCo 1 motherboard that is inside of this computer, and after part 2, there were some interesting things I wanted to check out before I continued testing everything and putting this machine back together. Also, in this video, I'm going to have a special guest on, a first time for my channel, where we're going to talk a little bit about what this machine is all about, these CoCo repacks. So stay tuned for that. Don't forget, down in the description, there's going to be time links. You can jump to different parts of the video. So if you want to watch that interview, you can do that, or other parts of the video, you can just jump straight to them. So without further ado, let's get right to it. In the last video, when I was working on this motherboard, it seemed that all of the memory was bad. I ended up having to change it all out. When I posted the video to my patrons early access, there were several people who mentioned that a possibility for what damaged the RAM was incorrect jumper configuration before I got this motherboard. As I pointed out in the last video, on these early motherboards, there are actually jumpers that let you select whether you have 4116 DRAM or 4164 DRAM installed. I'm not actually totally sure what kind of DRAM was in this. These are two of them right here. The rest are sitting over there because these have custom Radio Shack part numbers on them. They don't have the normal Motorola part number where I could easily identify what type of RAM it is. I could tell that the jumpers on this motherboard, though, were configured for 64K and not 16K, which are the two options available on this motherboard. Now, the main difference when you switch these jumpers between 16K and 64K, besides the fact it changes the amount of memory the computer has, is that 16K DRAM chips, the 4116 type, require -5 volts and 12 volts for bias voltages. Now that's in addition to the normal 5 volts. Of course, these DRAM chips that I have on here now are the normal 4164s, like on a Commodore 64, and those are simply 5-volt chips. They generate their bias voltages internally. If these chips that were on here were indeed the 64K DRAMs, and at some point someone had the jumper set incorrectly to 16K, what that would do is give these chips, well, the wrong voltages, which would surely damage them. Now, I had several people ask if I could use the Retro Chip Tester Pro to actually see if the DRAM chips were indeed damaged, at least according to the Retro Chip Tester Pro. I didn't do the test in the last part because, well, the DRAM chips were clearly not working, so I didn't really need to do any testing to see if they were bad or not because, well, the fact is the computer didn't work, so yeah, they're bad. But I had a bunch of people ask, so why don't we take a look to see what those look like in the tester. Now, first thing I want to do is I want to look up the part number on here and see if I can figure out what kind of chips these are. Now, unfortunately, the Sharpie mark that I made on them has obscured the markings, so I'm just going to use some alcohol to clean the chip off. Luckily, 99% IPA, which I have in my little spray bottle right here, will make quick work of that Sharpie. All right, these chips are from 1983, 33rd week, and the part number is 8040517. Well, actually, take a look at this. The CoCo 2 was sold in the 16K and 64K models, but the 16K used 16K by 1 DRAMs, but the chips are not the common 4116, and they are instead 6665 chips with a Radio Shack part number of what we just read, which only use a 5-volt power rail rather than the triple voltages used on the 4116. Well, I have to say, I don't think I've ever heard of these chips. And I don't even know if the Retro Chip Tester Pro can test these 5-volt only chips. Now, with 100% certainty, the motherboard here is a CoCo 1 motherboard and not a CoCo 2 motherboard. Now, because of this matching part number with what's in the article, and I also found some other references to that part number, that these are 16K DRAM. So obviously, this thing was not going to work set to 64K with 16K DRAM because you're going to have looping memory buffers. Basically, it's just going to show 16K 4 times throughout the entire memory space. So no wonder why this computer was crashing. Okay, I've done a little bit of Googling. I started by looking for that Motorola part number that this Wikipedia article mentions, 6665. I think this article is incorrect because we have an original Motorola product book here of all their ICs in 1980, and the 6665 right there is a 64K DRAM chip. Here we have the Motorola 4116. This is going to be standard run-of-the-mill, and we just check out the voltages here. There it is, -5 volt, +5 volts, and +12. So this is a standard one that you'd find in Commodore PETs and all sorts of other things from the 80s. Take a look at this, 4516, and this is also 16K DRAM. And look, this one only has 5 volts in ground. So this is potentially the chip that the article is talking about. And look, it says here, upward pin compatibility from the 16K DRAM, I don't know why it has the part number of the other one, to the 64K one, which is the MCM6664, and I guess the 6665. Here's a typical pinout of the 4164, so the 64K DRAM that's used in all sorts of machines. We have 5 volts down here on pin 8, ground up on pin 16, and pin 9 is address line 7. And taking a look at this 4516, the only difference really is that address line 7, which is on pin 9, is just not connected. So these 4516s would be an absolute direct upgrade path without having to change any voltages. But I have to say, I've never seen these used. Let me keep going through this PDF to see if I can find the 6665 that the Wikipedia article claims is the chip right here that's in this machine, and see what the datasheet says exactly. And actually, look, we don't even have to go anywhere. It was right here. I was scrolling by this page here. This has a pin comparison between all the different chips. So absolutely, without a doubt, the MC6665 is a normal 64K DRAM chip like that would be on a Commodore 64. You can see it has address line 7, it has no connection up on pin 1, which I can tell you is exactly what's on a Commodore 64 and what I put on this motherboard right here when I replaced these chips. Okay, and I've found the TRS-80 Color Computer 2 service manual, and we can put any conjecture to rest. The Wikipedia article is absolutely wrong. The 16K DRAM chip is a 4517, so it's correct in saying that it only gets 5 volts, doesn't need the other voltage rails. There's that part number 8040517. So absolutely, without a doubt, this is a 16K DRAM. Now, what sucks is I just looked through all the RAM testing menus on this device here. This is Retro Chip Tester Pro, and it does not support testing those particular RAM chips. So the only way to really test for sure to see if these are good or bad is to see if this motherboard can be set to 16K mode without damaging these chips by sending the voltages that are not supported by the chips. So let me go try to find the schematics for this specific motherboard here to see if I can figure that out. All right, with a little searching, I was able to figure out that this is an F revision motherboard, which is the very last version of the CoCo motherboards, cost reduced. So probably does do this weird 16K DRAM with 5 volts. Let's see if I can figure that out for sure. I'm on the Color Computer Archive, and unfortunately, while there's a lot of documentation here, it's not very good at describing which schematics are for which machines. 26-3002, and you go back to this article here, it says that this motherboard was used in the 26-3002A machines. Is that different? I don't know. This is the file that just says CoCo 1 schematics, and clearly this one has the 3 voltage rails. So this one is not correct for this machine. It only has 3 pages here, so that's not the right one. Let's see this other one here. And in this manual here is a picture of the CoCo 1 motherboard, which clearly doesn't match this motherboard at all. The chips are in a completely different orientation. So unless there's another one in here, no, there's not. So I guess no schematics exist for this particular revision. So I think the only thing I can do is take these RAM chips out and set the jumpers to 16K and then just measure the voltages that are coming out. All right, the machine's plugged into power. It's actually turned on right now. Multimeter is ready. Let's see what we see on here. We should be just seeing 5 volts, and we are 5.97. Let me swap those jumpers around. For changing the jumper configuration, there's a jumper there, and there's one 64K jumper here, which was wire wrapped. I had to pull the wire off there. I'll put a jumper back on there. When it's ready, if this motherboard is supposed to be using the 4517 chips, that means that this should be 5 volts, and it is not. Look at that. We're getting, can you see it? Yes, 11.7 volts right there. The other pin here should be 5 volts. That's right, it is. And on pin 1, we should be getting -5 volts. All right, so this segment has been kind of inconclusive, but we figured out a few things though. So first off, Wikipedia article is wrong with the part number for the Motorola chip. It's a 4517, not a 6667. It is right about it being 5 volt only part though, those 16K DRAM chips. So that is absolutely what these chips are here. I don't know if those chips work or not. The Retro Chip Tester Pro cannot test them, at least the firmware that I have. And they are definitely incompatible with this Rev F CoCo 1 motherboard. And setting the jumpers on here to 16K absolutely sends plus 12 volts and minus 5 volts to the DRAM chips that are in there. So if you set those jumpers wrong and you put 64K DRAMs in there, or these particular 16K ones as well, those chips will be damaged. So make sure you do not do that. Obviously on the CoCo 2 motherboard, the later ones that use this particular 4517 chip, you could set the jumpers incorrectly and it will not cause any damage. If you try to use these 4517s in place of 64K DRAMs, no damage will happen, but the 16K that's in this will be mapped 4 times into the address space, which of course will result in most likely a non-working computer, especially as it goes to test all the DRAM. As soon as it gets to that first repeating bank, it's going to overwrite the beginning of the DRAM, which is where the 0 page is, which probably will immediately crash the computer, which is almost certainly what was happening right here. What I'm going to do is I'm going to take off this Sharpie here that's on all these chips, and I'm going to bag these and mark them as MCM 4517s 16K by 1 for the future if I ever do need any of these chips, because my assumption is these chips are probably totally fine. While I'm swapping chips on this motherboard, there was something else that people had asked me to do, and that was test to see if this bad CPU actually worked on this machine with working memory. Now I'm 99.9, I mean there's so many nines after that point, sure that this chip is totally dead, but just for completeness, let's swap it out and make sure that it's definitely a bad CPU. Before I put the bad one in, let's turn the machine on just so you can see what it looks like with no CPU. So we're just getting a whole bunch of stripes basically. So there we go, that's what it looks like. We turn this off, pop this bad CPU in, and I'm gonna say it's gonna look exactly the same. And it does indeed. Exactly the same. And that's because when we were on the oscilloscope last time, this CPU, the bad one, isn't even attempting to execute code. All it's doing is sitting there trying to read from ROM over and over again, the very first byte. It's supposed to iterate through 2 bytes in the ROM chip and then jump to that location and start executing, which it absolutely is not doing. So putting the good CPU back in, we turn it on, and there we go. We have a working system again. Okay, so next up, I want to try to run some software on this particular machine. I mean, I've seen it at the basic screen. I ran a simple program, it worked. But I think running some actual software is really going to put this thing through its paces to make sure that it fully works. But I can't do that without plugging a cartridge into this cartridge connector here. But I do have this disk interface card here. This is what was inside the machine there to run the disk drives. It has this little extension cord on here that allows this thing to flip over like this, so it won't be sticking out the side of the motherboard like this if this connector had not been changed to a right angle, or it won't be sticking straight up, which I don't think there's any room inside the machine. The funny thing is, with this little handy extension cord, this connector didn't really need to be bent over like this. It could have stayed like that, where it would have gone and this card still would have been able to fold over like this inside without any problem. The thing is about this disk controller is I don't know for sure inside the external case if the PCB has the chips up or the chips down. And you have to think, if this connector were in its normal configuration, this card is either plugged into the side of the computer that way or that way. Which way is it? Well, one easy way to figure this out is the motherboard is supplying power to this card. So when we plug this into the connector, if it's plugged in correctly, that means the 5 volts and the ground on these ICs here will match the 5 volt and ground that are on the ICs on the motherboard. So the connector is plugged into the motherboard and it's plugged into the card the way I think it should be. Now let's flip this over and I'll move this out of the way here, and I'm going to grab the multimeter, and we're going to do a few continuity checks just to see if 5 volts and ground are matching on the TTL logic chips on both of these cards. Alrighty, so I'll pick one of the top pins here and we'll use this TTL chip right here, and we're getting continuity, so that's correct. And then the 5 volts down there, which is over here, which is right there on that pin. There's a little bit of oxidation on the pin, which is why we're losing continuity there. Come on, there we go, less than an ohm, so that is good. So that tells me that this card, the disk controller card, needs to be plugged in this way through this extension cord. So if I turn this thing on now, I think we should see the disk message on the screen. Let's give it a try. Okay, there it is. So with the disk controller up and running, one of the things I noticed about the ROM that's on this board is that it is version 1.0 of the Disk Extended Basic ROM. I did a little bit of research and it turns out there's actually a 1.1 ROM, which obviously is a little bit newer, and you'd think that newer is better, probably fixes bugs. I couldn't quite find a changelog, but I think it's time to upgrade this controller to 1.1. So I used the Data I/O 2900, and that's what the interface looks like to actually make a new ROM chip. And here it is, the Disk ROM 1.1. It's an AKE ROM, and it goes right here on the disk controller card. One thing to keep in mind if you're doing this is the ROM chips that are on the motherboard, the notch is towards the back, and on the disk controller card, at least with the case open like this, the notch is towards the front. All right, power it on. Let's take a look. Oh, I must have a bad connection there. There we go. Disk Extended Color Basic 1.1. There we go. And just to avoid any potential confusion, this is the original ROM chip that was on there. Since these all have Radio Shack part numbers, I made up a label so that I can easily identify the chip as well. There it is, Disk 1.0. We are slowly inching our way towards a working system. The next thing I think I needed to try is see if this disk controller actually works, which means I need to hook up a disk drive to it, and let's see if we can load some software. For testing the floppy drive, I'm going to use this. I've shown this before on the channel. It's an old CD-ROM case, and it's got a 360K disk drive in it, and I have the cable just running out the back here. This case has an internal power supply, which means that this thing is nicely self-contained. It's very similar, actually, to the disk drive that would have been used with this disk controller card back in the day. Alrighty, the disk drive is connected to the disk controller. Disk drive is on. Let's turn on the computer. There it is, Disk Basic 1.1. I have a floppy disk here. Let's slide this in. I'm going to issue the command drive 0 to set the default drive. I'm going to initialize the disk, or format it basically, which I think is disk DSK-INI. And we hit enter. And right now it absolutely is formatting the disk. It sounds totally normal. The light's on, head is seeking. Awesome. All right, the format is complete. Let's just write a little program here. It's going to be super simple. The keyboard is not working very well. A lot of the key switches are dirty, so you get double key pushes or you don't get anything at all. Like the period key, that's not working at all, but the number pad one sort of works. And there's the little program, so it just prints my name. Now we're gonna save this to the disk, :0. That's gonna save a basic file to the floppy disk. Oops, close quote, hit enter. The disk is accessing. There it is. Now we type dir. There it is, yeah, file is saved. Let's power cycle the computer. Here we go, drive 0. dir. Let's see if we see our saved file. There it is. Load. Adrian /BAS:0. And we type run. There it is. It's working. I have to say that's actually the first time I've ever actually used the floppy drive interface on a CoCo 1 before. So that leaves us with two things that haven't been tested. It's the CRT and television chassis that's in here, along with the two floppy drives and the power supply that runs them. Now, since I opened this computer, I have been taking a look inside, and I've noticed that there's some wires that have been chewed a little bit. So that implies that there's some snack-stealing friends that have been inside this computer because it wasn't really screwed together very well, and there were big openings on the back as well. So they have eaten through this wire, which goes from the head assembly to the analog board on this top floppy drive. The bottom drive does appear to be okay. And then when looking at the television PCB here, it has a couple power wires that run to the tuner assembly. One of them is still connected, but this other one, the red wire, isn't anymore. And I noticed it's a bit too short to even make the connection, and I'm noticing that there are little teeth marks on this wire as well. So they've eaten through that. Luckily, with some spare wire, I should be able to reconnect these chewed through leads. Unfortunately, with the two floppy drives here, I don't think they're ever gonna work. As you can notice, they're a little bit cleaner than they were when I took the machine apart. I just gave them a quick wipe down. But when I did that, I stuck my hand underneath here and I tried to turn the spindle. While it's turnable, it's very, very hard to turn. And I've worked on plenty of these drives, and that spindle should be very easy to turn. So I think the fact that this was stored out in a barn, probably here in Oregon, which means that it was subjected to pretty cold and damp conditions in the winter and then hot conditions in the summer, has basically turned the grease inside of both of the spindles on these disk drives to something that doesn't want to turn very well. Actually, the bottom drive, because I did spin them a little bit by hand last night, bottom drive seems to spin a bit better than the top drive. The top drive is very, very difficult to spin. The bottom one though, this drive may be okay. Okay, so I'm gonna focus on one problem at a time. Let's focus on the CRT board. So first thing I need to do is fix this chewed wire. Now I decided to go ahead and use butt connectors. Butt connectors are quick and easy and they do work just fine. And there it is, I've spliced the wire. Just make sure you give this a little bit of a tug afterwards to make sure that it's a good firm connection, and that should be good enough. Now there's one more problem with the wiring on this TV, and it's this wire right here. This is the CRT ground, and it goes to the corner of the CRT there, and it's connected here to the aquadag or the DAG. The ground lead needs to make its way back to the CRT board, because if you think about it, the CRT itself is a large capacitor. Remember, there's the high voltage cable that goes to it from the flyback transformer. Well, this part of it on the outside is the ground that needs to go back to the CRT board to complete the circuit. Originally, it appears that this wire was actually connected here to this wire. It seems to be an earth ground lead that was connected to the earth ground that was on the power cable that goes into the wall. This is not appropriate. The CRT should not be grounded to this because the television set board over there is connected with this power cord, which is not earth grounded. It's only connected to the live and the neutral. So even if the neutral wire that goes to the TV board is somehow connected to the main ground of that PCB, then it would make a very roundabout trip for the CRT ground to go through my house's ground wiring to the neutral wiring in the panel and then back to this through this wire to the TV set. This is not appropriate at all. Somewhere on this PCB is a specific point or a lug that's designed to connect the CRT ground. Now, I don't know where that is because there's a whole bunch of test points and stuff on this board. So what I'm gonna do is I'm gonna connect it to the PCB's main ground plane. This is the flyback transformer here. We're looking at the bottom of the PCB. This metal point right here is the clamp that holds the flyback together, and I think it's connected to pin 5 here, and it goes to this trace that runs around the entire board, and it's connected to stuff like these shields here. That is an appropriate place for the CRT to be grounded to. So let me grab the soldering iron and connect up a wire to the appropriate point on this board. Okay, so the wire is soldered onto the PCB right here in the corner. That's like one of the chassis grounds, I guess. And of course I used a butt connector to connect it up to this existing wire that's going to the CRT. So that should be all the wiring for this television set for us to do some testing. Now I have the CRT board sitting kind of where it's supposed to sit. I think originally it was like hot glued in here or something like that. One of the things that's a bit scary is the back of the CRT right here is very close to these shields right here. And this has possibly like a, 150, 200 volts on here. So you wouldn't want that touching. That would be a bad thing. So I'm gonna cut up a piece of this plastic here, which I think is from an old Macintosh analog board or power supply or something like that. And I'm gonna cut a piece and I'm gonna double stick tape it to the back of the little PCB there, just so those pins are not exposed. All right, well, that's not working so well. I was trying to use some 3M double stick tape there, but with all those little pins and stuff on there, that is just not working well. I think I'm gonna have to heat up the hot glue gun and we're just gonna have to hot glue this little piece of plastic on there. While I wait for the glue gun to warm up, let's just take a look at what else is going on here. We have the speaker here, which looks like it was hot glued onto the top right here. So probably what I'll do is hot glue this back on there, and then I will just drill some holes through the case so we can just screw this on. All right, I have attached the PCB with one screw. There was actually a screw in the power cord here, and I put it through one of the holes into the back of the case here. So this is actually held on. It looks like I can see hot glue remnants. So there's a lot of hot glue as well holding this on, but it's kind of in place right now. It's okay enough for testing. Now this little plastic piece is glued onto the back of the PCB. I feel it's a little bit less dangerous than having it so close like it probably was when this thing was in use. All right, everyone, it's the moment of truth. I have a power cord that goes over to the outlet. It is actually powered up right now. It's screwed onto the terminal block. I did disconnect the power supply there for the disk drive, so it's just the TV connected, and it's currently off. Obviously, nothing's happening right now because on the volume knob that's screwed through the top of the case, it's also the power switch. So I think we're ready to test. Just one last double check here. This is okay. This is the RF connection. It's not connected to anything. The ground for the CRT is hooked up. The high voltage is connected. I think here we go. We are ready to try it. That's not it. Something's happening, but I don't think there's any high voltage. So there's obviously power. Because I hear buzzing on the speaker. Oh wait, no, there is high voltage. Hold on, everyone. Oh, I heard high voltage. Definitely not seeing an image. But when I shut it off, I heard sounds like high voltage collapse. Now there is a brightness and a contrast knob here. I can't really adjust them while I see the front. And I can't really position a mirror. That's normally the tactic for seeing the front of a CRT. Oh, and I can see the heater on the CRT is glowing. So definitely some kind of voltage is happening on there. The pot for the audio, I think, is very, very dirty. So that might be why nothing is happening there. Let me turn off the lights. Oh, would you look at that? There is absolutely deflection happening. I see it. I see it. I think these pots are extremely dirty. Well, I'm going to pull the power cord out. Oh, I saw a flash when I did that. And I'm going to hit those pots with a whole bunch of contact cleaner. Alrighty, let's give that a try again. I think I've cleaned up the pots, and I also hit the brightness control, which is down in there. Certainly no audio. I think there are some massive problems with this TV set, unfortunately. All right, well, there's definitely brightness, because turning up the brightness control, we see raster there, and there appears to be good deflection happening. So I'm hearing a hiss through the speaker, so like the audio amplification is working. But what I'm not hearing is any static, and we're not seeing any static on the CRT, we're just seeing a black image, basically. And I have the brightness turned up enough so we can see the retrace. We have deflection, but we're definitely not getting any kind of video signal from the tuner or the IF on this CRT board. So I'm gonna say that this thing has definitely got some faults going on. Let's turn the knobs here. Yeah, it's like nothing happening on the tuner. Oh, did you see that? There was something there. Is this just so dirty that the tuner's not working at all? Interesting. Boy, it's acting like something's happening here, isn't it? We spray some CRC into the tuner. Look, we're getting little bursts of static there. All right, well, I'm gonna work on the tuner a little bit, spray some more cleaner in there. This seems to be coming back to life. Let's see if I can get this to do anything. Oh, check this out. So the output of the tuner, which is on the IF frequency or whatever this set needs, I don't know, it's like 43 megahertz or something. If I just move the wire, look at that. So it's just a bad connection in the tuner for this cable here. All right, here's the tuner. This is the RF input that would come from the computer itself. So that would be channel 3. This is the wire that goes from the tuner back to the actual CRT board. So this is on the IF. And look, when I move this, we get a signal. So that is the problem. So investigation time. All right, well, I took the tuner down, and as you can hear, there's static right now. I think what happened is this capacitor was squished up against the drive chassis and it was shorting against the chassis. So that was actually what was killing it. And just moving the wire around just happened to move the capacitor. So with the set off, I'm just gonna move that cap, and I think it should be fine now. I'm just gonna have to put a little spacer there maybe so it doesn't squish that down against, I'm not sure what that was shorting out against, but it seemed like either the ground on the cable there or something. So yeah, I think this should be fine at this point. Alrighty, the tuner is back on, and I had that little cassette box that from part 1 was I don't know, just loose in here, and I stuck that behind the tuner so it doesn't jam that capacitor up against the drive cage. Let's turn this on, see what happens here. All right, we're getting the static sound, which is a good sign. That means the RF seems to be working. There it is. The CRT is so dirty, but I see what looks like pretty good looking static on there. So that means that the TV is working, and my connections here with the ground and stuff all worked. So the hot glue gun is warming up. I am gonna slather a bunch of hot glue all over that board on the where it's touching the back case here. So that's gonna hold it in place. That one screw is not gonna be enough. Okay, so the speaker is hot glued back into the case, so is the board here. The VCR is hooked up to the tuner. It is playing a tape. Let me turn the TV back on, see what happens.
Down here at the bottom,
whoa!
I
I happen to be on channel 3 already, I guess. Whoa, I'm tripping over wires here. And okay, not so good. There it is.
That board will be taking the videos.
There it is. My own videos. Playing on a TRS-80 Model, well, 3/4. All right, cool. So the picture looks pretty good, actually, considering how dirty this screen is. Let's turn that. Is that the contrast knob? Yeah, it's contrast. Okay. Let's try to clean the CRT a little bit, because it's very, very filthy there. All right, I turned it off, actually, while I try to clean this off a little bit. Oh, it's gonna be so dirty. So dirty. Yeah, that's serious filth. All right, I think this is clean enough to at least see if the image is sharp. Ah, yeah, this CRT it's sharp. It's still really dirty, but that's gross. Yeah, it's looking pretty good, pretty good. Alrighty, we're almost at the end here. The floppy drives are the last component I gotta see if I can get working. This power supply, it looks like a normal TRS-80 Model 3, Model 4 power supply. I see it's got a couple of reefers on there, so I'm gonna have to yank that off to replace those. And this is the homemade power connection that goes from this terminal block here, which incidentally is not energized right now, to the connector on this board here. I'm not going to talk too much in depth about working on these particular power supplies. All the usual power supply warnings apply. If this thing has recently been powered up, you don't want to be touching it because the capacitors might be charged at high voltages. So make sure you know what you're doing before you work on anything like this. In fact, this entire computer is like a hazard because of all the exposed wiring and the CRT that's open and stuff. So don't work inside of something like this unless you know what you're doing. All right, well, here's the power supply. Yeah, this looks like a bog standard Aztec power supply used in the Model 3 and probably the Model 4 as well. It's got a reefer cap there, it's got a reefer cap there, and actually has another one right there. So those have to be replaced, otherwise they can let out the magic smoke. Generally, these power supplies are pretty reliable. The only thing that can go wrong, let me think about it here, I think this small capacitor right here, this can have issues because it's right near these diodes here, so it gets hot, and that is required to start the power supply up. So if the power supply appears to be totally non-functional, it's a good chance it's that cap right there that just needs to be replaced. Typically, the rest of the caps on these types of boards are reliable and generally work perfectly. Okay, so we have 0.1, 0.1, and 0.1 microfarad. That's the value of these caps. Let's get them off of here. I often use these, which are hemostats, to pull capacitors off of boards. It just makes it a lot easier to grab them when they're in narrow spots. So right now, for instance, I'm holding onto the cap, so I can just heat this up right here. And then it pops the cap right out without any fuss. There we go. And that popped out very easily. These tools are amazing, I gotta say. Oh, sorry about that. I forgot to turn my wireless microphone on. So for the second time in this video, you had to listen to the crappy audio from the top-down camera here. I have some replacement caps here, two 0.01s and a 0.1. Lastly, we have this troublesome cap right here. I could check it or I could just swap it. It's 330 microfarad, 16 volts. I think it's easier just to take it out. It always fails on these power supplies and just keeps them from powering up. And with the hemostats, that came out super easily. You know, while it's out, let's just give it a quick test. Okay, LCR meter is out. These leads are so short, I don't think it's gonna fit into here. Just barely making contact. Not really. This is what you use with this thing when the leads are too short. So you pop that in there, and then we just connect it up with the clip leads. All right, well, there it is. The cap is actually fine. It's 0.15 is the ESR, ohms, 281 microfarad. So there's nothing wrong with that cap. Should I put it in or just swap it? I'm gonna swap it anyways because, like I said, I've had to replace this cap many times on things. So let's just do that. Here's a new cap in the tester. There's 330 microfarad, 50 volts, and as you can see, 0.12 ohms, and it is 289 microfarad. So basically, it's performing exactly the same as the one I just took out. Of course, I'm replacing it with a no-name cap, so to be honest, this might be worse off than the original one that's on here, but anyways, whatever. It's out. I'll do it. Now, if you watch my channel, you know that I'm not a fan of recapping for the sake of recapping. It's better to understand what the fault is with what you're trying to fix first than just randomly changing out caps, hoping it's going to fix the problem. I'm not going to get into it too much, but you can cause damage by taking caps out. You might put one in backwards, you might rip a trace or lift a trace, or you might change out a special bipolar cap and put in like a polarized cap in there, and that could cause damage to the circuit. So that's why I just don't like to recap willy-nilly. So anyhow, I think this power supply is ready to go back in the chassis and test it out. Alrighty, as you can see, the power supply is remounted inside the case. Now I have the motherboard sitting in here because the transformer for the CoCo actually has a wire that comes out of it. And I talked about this in the first part. And this actually runs up to the terminal strip here, and that provides the power to the monitor and to the disk drives. Now, the funny thing is originally the power cord from the CoCo just ran out the back of the case, and there's no actual power switch on this machine, which is actually funny because this is the location of the stock 115 volt power switch. The person who made this could have retained this power switch and ran the hot wire through that switch, and that would have been like a master power switch for this entire machine. As it sits right now, plugging this into the wall is actually going to energize the disk drives, and the monitor, well, that will be off because it has a separate power switch, and then the computer as well has a power switch, but of course, it's right here on the motherboard. It's not reachable when the lid is on. So I assume originally this was connected to like a power strip or something that turned the whole thing off or on. As it sits right now, with the power supply mounted in there, I have the multimeter at the ready, so I can plug this in. That's gonna power up that controller, and the disk drive should have power, and I'll check for 5 and 12 volts on the power connector on the disk drives. So for the moment of truth, when we have the camera pointed at this power supply in case the smoke gets let out, I'm gonna plug this into a power strip over here, which is turned off right now, and I'm gonna hit that power switch, and let's see what happens. All right, well, the TV came on, and I heard the disk drives click. Let me turn the TV off. The fact that there was a click out of the disk drive meant that the power supply, I think, is actually running. I know you can't see where I'm probing, but let's see what this thing says. 11.7, that's fine. And this one, 5.07. So we have good voltages on that power supply there. All right, gone ahead and I killed the power to the entire system because we're actually ready for testing. I can't even believe it, but it's been quite a long journey. I've had this thing open up on the bench for a good while now, and I am ready to see this thing at least working and back together. So let me get everything reconnected. And after long last, everything is actually connected and ready for the very first test as a system. Unfortunately, the power strip that this is connected to is over there, so I'm gonna have to reach over and block the camera a little bit as I turn it on. But there it is. Okay, the TV came on because I did turn that back on. The computer is still off. So here's the power switch for that. And there it is. It's working. Wow, there's a lot of interference though. And let's see if the keyboard is working. Yes, it is. Numbers are working. Hopefully the camera is focusing on that. There's definitely quite a bit of interference, and I really do have to wonder if it's just always been this way. The RF modulator output on the CoCo 1 motherboard hooked up to a modern TV was rock solid, no interference whatsoever. So this is unfortunately probably as good as we can get for a picture without trying to do a composite mod or something like that on both the computer and on the analog board that runs the CRT. Alrighty, so the question is, and I'm sticking my head into the frame here, Do either of these disk drives work? I'm not sure which is disk drive 0 and disk drive 1. It's determined by the position on the cable that's plugged into the back. I have a feeling the top one is going to be disk drive 0, which is the one that's broken. So we do have the disk basics. So if I do dir 0, oh, the bottom one's going. And you know what? The top spindle is actually spinning and the head is moving. Wow, okay. Let me grab a cleaning disc because we can be sure all this dust that was in here is on the heads in drive 0 there. So let me try and clean this thing. These are single-sided drives, so I'll be using my single-sided cleaning disc, which has a little piece of something stuck on there for protecting the foam pad. Ooh, it's very scratchy going in. There's a lot of dust in there. dir 0. Doesn't sound like it's really spinning it very well in there. Anyways, we'll see if it can read a disk in a second. Well, I made a CoCo floppy disk to put and try in this thing. I don't mind if this disk gets damaged because of the dirtiness or whatever. Let's see if it can read it. It's making very weird noises and unhappiness is happening. So while we're so close to having this thing back together, I'm not quite there. So I guess it's time to take apart these disk drives, which is a bit of a pain because the disk drive is mounted behind the power supply, so I gotta take that off again. I probably should have done this cleaning on the disk drive before I put the power supply back in, but live and learn. So I'll be right back. Well, I did take the 2 disk drives out, as you can see, and unfortunately, I don't have good news, not even a little bit. Unfortunately, both of these drives are bad. They don't work properly anymore. Let's start with the bottom drive. This is drive 0, the one that was kind of trying to work, but it didn't quite work. Well, as you can notice here, the board is really, really dirty, and actually the mice did chew at this wire here as well, but they didn't break any of the signals, so the signals are getting through properly. The issue with this drive is actually the spindle, and that's what I originally had worried about. If we look at the bottom of the drive, you can see the spindle here, and it has this sticker on here with these lines, and that is to help you set the RPM based on the patterns in the lines, and it's an interference pattern with your 60 hertz or your 50 hertz lights, depending on where you are in the world. I'm going to slide the floppy drive out of the system, and if we go to test RPM in here, this is IMD, then hopefully you can see in the camera that there's an interference pattern that pretty much says that this thing is running at 300 RPM. Thing is, if I put the disk in and I close it, look what happens. It slows way down. The problem is the spindle motor here only has so much torque to spin the spindle and the floppy disk itself, and the disk itself creates quite a bit of drag when you actually latch it. And because the bearing that's on the spindle here, and I think also on the top clamp, are both really gummed up and not in good shape, with the disk out, the motor is able to spin this at the correct RPM. It's able to overcome that friction. But with the disk in there, there is just not enough torque on this motor to overcome all of that friction. So we'll try one more time. I mean, I don't even know what RPM it's going, but it's way, way too slow. Now, if we let it sit a little while, I can see it's getting closer. Let's just keep running it here. It might actually speed up and start working. In fact, if we go to a line, I think this will keep spinning indefinitely. So it will eventually attain like 280 RPM, which is enough. Oh, look, it's starting to work. So it should read 36 when it's actually able to read all the sectors. You can see it sometimes is reading them. Okay, there we go. So you can see the lines now are relatively close and they're not moving that fast. So that means that it's actually close-ish to 300 RPM. But it's extremely unreliable because of the fact that as soon as you let it cool down a little bit, the bearing needs to come up to temperature before you can actually read the disk. And if we exit here and go to test RPM, we should at least get a reading now, maybe. Let's see. Oh, there we go. Okay. So 293, I've actually turned up the motor speed. There's a little potentiometer on the top there. And yeah, so this is about as good as this drive can get. But unfortunately, when it's sitting down like this in this configuration, it seems there's even more drag on the bearings and stuff that make it not work. Let's see if it slows down now with IMD. It's trying, yeah, look at that, 260 RPM. When it's on its side, whatever reason, there's less friction than when it's sitting like this. And unfortunately, this is the way that it's in the computer. So unfortunately, there's really no way to fix this drive without completely disassembling it and removing those bearings, which are pressed in, and it would be possible with a press and stuff, but that's beyond my capabilities of doing down here in the basement. So unfortunately, this drive is no good. And incidentally, this drive is made by Texas Peripherals. You can see the sticker on the bottom here. That is a company that I think Radio Shack owned or they directly partnered with. And this drive is a clone of the Shugart or the Tandon drives or whatever. It's all right. And then now let's go to the other drive. So this is actually a Shugart SA400. This was in the top drive, drive 1. This is the one where obviously you could see the mice ate through the wires there. Now, that would be possible probably to do some kind of microsurgery on this to try to add some bodge wires. And then this drive might actually work. In fact, what's interesting is when we flip this over, it's quite difficult to turn the spindle, just like on the other one. And let me remove the drive belt here. And yeah, I mean, this should spin quite freely and it's still pretty stiff. This one seemed to run at 300 RPM when I spun up the drive. The problem is, there's actually an issue with this drive beyond the mouse eating the wires and the potentially stuck spindle. Flipping the controller out of the way, you can see that this is the normal SA400. I've gone ahead and I've lubricated this track in here that does move the motor. And yes, this is the way the SA400 and the SA390s work, like on the Apple II disk drives. The head assembly seems to move properly. I can get it to move around using IMD. The issue is this right here. This right here is the sensor for the index hole. And as you can see, it's just sort of flopping around. What's happened, if we move this out of the way, is that the little holder, which is this black thing right here, has gone ahead and broken. Now the LED, which is on the bottom, I cleaned it, but then I realized that it's not gonna work because the original plastic holder that the sensor goes into actually has a little like slot cut in it. So as the index hole passes it on the disk media, it's only seen for a very brief instant by the sensor, and that's with the LED shining probably infrared light up to the sensor. So that whole half of that is gone. It broke away, and I can't just glue this sensor back in place here because you absolutely need the slot over the LED so that you have a nice sharp beam that is only detected as the index hole passes over a very specific point. So without a replacement part of that, there is no way that this drive can work either. So that is a bummer. Both of these are bad. I'm just gonna stick these back in the computer so at least it looks complete. And then I think I'm gonna just run the cable out the back and I'll just temporarily hook up an external disk drive so we can actually see the machine up and running. And this is it. We're nearly to the finish line, so it's time for a little cleaning. Machine is really filthy. And I used an old t-shirt because I knew I was throwing this away afterwards. And there we have it. The TRS-80 CoCo repack is finally back together. Even after a cleaning, the case is still in very rough shape. I think a little bit of magic eraser, a little bit of elbow grease using baking soda might clean it up, but of course this case is all cracked and broken, so it's not really ever gonna look very good anyways. Since the internal floppy drives are broken, I have this external one hooked up as drive 0. I also hooked up and ran one joystick outside of the case so we can try a game on this thing. And here's the moment of truth. Let me hit the power switch. I think it should be on. Look at that interference on here. I bet you anyone who used RF on their 8-bit computer back in the day probably remembers interference like this, and you just dealt with it because there's not a whole lot you could do. The low-cost television set that's in here just doesn't have very good RF interference rejection capabilities, so you're gonna end up with stuff like that, especially with an unshielded 8-bit computer sitting right inside the case, right next to the tuner board. I have a floppy disk in the drive here, which I was trying to use. Let me put this in the drive in the back, and let's load it up. Here we go, this should load up the program. If the disk still works after being inside this destructive disk drive. Oh, it seems to be loading. Turn up the volume. There we go. Adrian's Digital Basement 8-bit dance party on a green screen with a lot of interference. I have to say, it's kind of funny to see this type of graphics on something that looks like a TRS-80 Model 4 because it's very incongruous. It just doesn't go with the machine. You're just used to seeing high resolution text on this thing. So to see this graphics with all this interference, it's just very strange. I have a game disc I made. Let's try this. All right, and this is the game Doubleback. And unfortunately, the graphics are almost unreadable on this television set. Let's see what happens if I try to adjust the contrast. Well, if I turn it that way, we can kind of see the graphics at least. Let's start the one-player game here. This is a pretty fun game. It's kind of like Snake. Oh, there we go. Okay, so you have to encompass the shapes and get scores, and sometimes they move around. And interesting is it's actually really easy to play this game with this particular joystick. This joystick is very well suited to this particular game because you can move at various speeds. Well, one thing I can say for sure is this monitor is definitely better suited to text mode. And that's really caused by the fact that this is a black and white television in here and not a computer monitor. I've talked about this on the channel a little bit. These cheap black and white televisions don't have good DC restoration, and the overall picture brightness is affected by the contents of the screen. A well-designed composite monitor of the era was not designed that way, so it had much more stable overall brightness where you could have a little bit of text or a whole lot of text or graphics, and you would still have a very consistent bright screen. I never fully understood why these cheap black and white TVs were designed that way, because color sets aren't like this, and I think better black and white sets aren't like this. It's really just these cheap ones. So a really good solution for this, which would result in a much better image quality, would be to composite mod the motherboard and then remove that television set and install a composite monochrome monitor driver board with this CRT. You'd get much better image quality, of course no interference, but also a nice stable brightness as well. Well, now that this computer is back together and working, I'm gonna have a special guest on the channel, which I think is a first, and we're gonna talk about these CoCo repacks. So who are you?
I'm Tim Lindner, and I'm a little bit of a collector and a little bit of a developer and a full-time CoCo nut.
Nice. So how long have you been into CoCos?
I got one before they released in the summer of 1981. My dad was an accountant and had a bunch of TRS-80 systems from the Radio Shack next door.
Whoa.
And when he said to the store manager that his son wanted a computer, store manager knew exactly what to get because they were filled in ahead of time of what the product line was going to be later that summer.
So the CoCos were like in a storeroom in the back still, and they're like, okay, here you can have this one before. Wow. So it wasn't the blue ones or any of those crazy blue ones, right?
No.
This was a CoCo 1.
It was a 4K CoCo 1.
4K?
Yeah.
Isn't that the same memory on the MC10?
Yes, that is the same memory. 3 years later.
So you could basically just like type a little program. And
you could type a little program. You could buy the program packs and have a lot of fun with that. It took a while for me to get my first program pack, which was Math Bingo.
Wow. Okay, that's really cool. All right, so I know you don't have that much of a physical collection anymore because you're working on more modern CoCo-related stuff, right? So talk about that.
Well, I really got into emulation around the year 2000 when I sat down and modified the 6809 core in MAME to be a 6309. And I got Nitrous 9 booting for the first time under emulation. That's
that like faster OS 9, right?
Yeah,
that's like modified to use the Hitachi chip?
Yeah, it's the faster OS 9, use the Hitachi chip, use the extra features of the chip. And that was a project from the 90s, mid to late 90s. And so it was really fun to see that in emulation. And I just keep up with MAME, you know, making sure it keeps working because drivers that aren't touched tend to break.
Right, okay, well that's really cool because I mean, the community that keeps MAME working, you know, the people that make sure it's actually doing what it's supposed to do, it's amazing because there's just new stuff added constantly. And people don't necessarily think about MAME when they're thinking about emulation. You go to find an emulator, like a standalone emulator, but really MAME does it all. And of course, it's powering all the emulation on archive.org, right?
A lot of it. They use a couple different emulators that they compile with Emscripten so that it runs in the x86, the low level machines, so that you can run operating systems and programs like that.
All right. Okay. So I think people have been watching my series on this crazy monstrosity of a machine, the CoCo repack. And this machine actually was given to me from you. So I'd love to know a little bit more about it. Like, how did you end up with it? And if there's any kind of backstory. And of course, then what's the story with the whole repack thing? Because to be honest, when you first told me about the repack, I had never heard of people doing this. I've come to find out that it was actually a lot more common than I realized. So yeah.
Well, it started with a friend of mine who I consider a super collector. He's out in the Midwest, Brian Weisler. I get this message saying, Tim, there's something for you that's near you. I follow the link, and there is a man moving out of Washington State, and he wants to get rid of the CoCo collection that he has sitting in his barn.
In the barn.
This is up in Washington where there's horse country, and I traveled about 45 minutes up north.
Okay.
Some beautiful horses.
I mean, that explains the condition of the computer, right? It was just uncovered in a barn for who knows how long, right?
So he told me that he's moving out of state, wants to get rid of what he can get rid of. He told me he's a former Radio Shack manager.
Oh.
And he says, oh, wait till you see this, wait till you see this. And he pulls out this Model 3, and I go, oh, nice Model 3. It's a CoCo repack, and I knew exactly who I was going to give this to at that moment.
Right, because I have fixed a lot of computers that have been sitting around a long time, like in barns or outside. They never work, obviously. The things, electronics is resilient.
Yeah.
Because as people have been watching this video, they see the machine is now running. So obviously it mostly worked. But yeah, okay, so he had this machine, which he obviously made at some point in the past. What's the backstory, if you know it?
Well, fortunately, he commented on the first video of this series.
Which I missed. Sorry, everyone. I can't read every comment, so I did miss that one. Tim told me about this, and I apologize to, I think it's Mike, right?
Yeah, Mike.
Sorry about that, Mike. But so I'll have to go find that comment and maybe pin it on that first video.
He said that as a manager, he would be able to get in broken devices. Got a broken Model 3 shell, got a motherboard that needed a little fixing, and he cobbled together, who knows where the TV came from, didn't get a lot of information on that, but he cobbled together the CoCo into the case.
So I guess like Radio Shacks, they must have done service in the stores.
Oh yes, that's how it worked.
And I'm sure they weren't doing like board level repair, but they, if they had a bad CoCo
Oh,
one,
incorrect.
They were doing in the stores?
In the technician. I worked at a Radio Shack store in the summer of 1990.
Wow.
And we had a tech there that did board level repairs.
So he could like swap out a bad chip if needed, whatever, like desolder or
Radio Shack had these wonderful service bulletins so that their techs could really narrow in on the problem, and it had step-by-step what exactly to do to fix it.
I mean, that's funny because that's the exact opposite of Apple Computer. Because even though Apple was selling computers since the 70s, they didn't allow their techs to actually do board level repair. You had to replace the entire motherboard and then send the old one back to Apple. They were very strict about the whole returns process. Like they didn't want loose parts floating around. Obviously, this computer was clearly an amalgamation of these old parts. So maybe they had a motherboard that was so damaged or who knows what that they put a new one in.
Right.
And the old one was just cast off to the side, and Radio Shack wasn't like, send it back to us, or Tandy back in Texas.
No, that costs money.
Yeah, right. So they probably just threw it in a pile, and so he probably was able to cobble together parts to fix it. So that explains a lot, because the bottom of the computer is a Model 3, the top's a Model 4, which has cracks in it, so maybe that was shipping damage when it got delivered to them, who knows. The disk drive chassis, half of it is gray from a Model 3 and half of it's white from a Model 4.
Wow.
The keyboard's a Model 3 keyboard. It has a power supply that looks like a Model 3 power supply, because I had to do a little repair on that. And then the CoCo 1 motherboard is the Rev F, the later version.
Very common.
Yeah, and then it's 16 or 64K support. But people watching this video have already seen me do this, but the bad RAM that was in it wasn't bad. It was actually CoCo 2 16K RAM, because that was different memory that's incompatible.
Another bits and pieces that he probably pulled together trying to get it to work.
So it's funny in a way, because actually with the RAM that was in that motherboard, it never would have worked the way it is now.
Which was probably why it was in storage.
It's possible. And
Because it got to a point where it stopped working.
yeah, so I kind of wonder, like, you know, maybe I just, it's very curious that like all these pieces, and then the disk drives, one of them was the Texas Peripherals drive, which is the Tandy used those ones, right? But one was a Sugart SA400, which was the original, the very first 5¼ inch disk drive was from Sugart. SA400 was it, and that's one of those two, the one that got mouse eaten and damaged. So
Very much shameful.
yeah, terrible.
Radio Shack would eventually made their own drives, but they definitely started with the Sugart drives. Everybody did. Everybody did.
So it's just like whatever, like one of them was really old, one of them was a little bit later, all hodgepodge.
Got CoCo 2 RAM late in his career. You know, maybe I can get these to work in here and solve some sort of problem he was having.
And yeah, unfortunately that it created a problem, but anyhow.
So this is really more than a repack, and that's why I knew I was going to be giving it to you.
Right.
This is a Franken computer, if there ever was something to be described like that.
I mean, you're right, because I've, you know, since making these videos, people have reached out to me who did repacks themselves, but they told me it was just a way for them to extend the life of their CoCo. And it wasn't like a broken machine. They just like stuck it into a PC case and, you know, rewired a PC keyboard so they could use that externally.
Yeah, I got lots of stories of people using Model 3 and Model 4 cases and Model 3 and Model 4 keyboards. But then the PC took over, and that clone market created this whole huge, cheap boxes with power supplies that you could fit a CoCo into.
Yes.
And they went. I've seen stories going a little bit further where they also put a multi-pack inside the case.
So what someone I know was telling me about his CoCo 3 repack in a PC case, and it had the multi-pack, hard drive controller, floppy drive controller, RGB monitor, rewired PC keyboard, all in like a full-size Gateway 2000, you know, gutted case apparently.
It happened a lot.
That's amazing. The loyalty of CoCo, the CoCo community to their computers is absolutely amazing, because most people would have just thrown away their 8-bit computer and got something like a PC or whatever.
Real missed opportunity for Tandy to, they really wanted the Tandy 1000 line, the CoCo people to go into the Tandy 1000 line, and the Tandy 1000 is a nice PC as far as PCs go.
And incredibly popular for Radio Shack, right?
But people were looking to organize their space, and CoCo people are highly technical people that solve problems, and one of those problems is getting all that equipment into a tighter space, especially with a multi-pack. You know, the
it all sticks out the side.
Yeah,
right?
it can get kind of wide.
I mean, the Model 3, 4 Frankenstein machine here, it's scary inside, because there's like live 120 volts floating around in there. There's like a CRT voltages all in there, and everything is very precariously installed in there.
Yes.
So a repack that had it in a PC case seems like a much safer affair.
Yeah, keeping the monitor out of the equation.
Yes.
But you have to admire this man's gumption.
Absolutely. I mean, taking an old black and white television set and like saying, we can reuse this. And I mean, unfortunately, the image quality is just terrible because it's not composite, it's RF.
And there's so much interference inside that box.
Yes. In fact, you had a CoCo 4K, but you said back in the day, obviously we're using it with the television.
Yep, yeah, the family TV.
Did it have interference
Oh,
lines?
yes, it did. Yeah, the cable's too long. It's not grounded properly. The RF cable that came with the machine.
Yeah.
The switch box introduces a bunch of noise, and we didn't have direct connection there because I couldn't monopolize the TV. That's for sure.
Right. So you used one of those switches on the back, right? TV and computer.
Yeah.
It's funny in a way, because I mentioned that in the video, that like the interference that's on this Model 3, 4, CoCo thing probably was what a lot of people experienced. Especially, I know lots of people who had a Commodore computer or a CoCo, and they had a little black and white TV, one of those cheap ones from J.C. Penney's or Montgomery Ward or whatever, and they just have terrible performance when it comes to using computers with them, because the computer's generating interference and stuff, and obviously with the motherboard in there, it's no longer shielded. There was an attempt by Tandy to shield the motherboard.
Yeah.
That's just all thrown away at this point.
The FCC is halfway down the street right now.
I know there's vans outside right now, and they're like, what is happening here? I do not like to keep my RF shields on any of the computers, but obviously when you're using composite or RGB or whatever, it doesn't matter. You don't sense it. But Anyhow, okay, so any other cool things about the repack that we want to talk about at all? I mean, I don't know. And then
To see the channel changers, when you do that reveal in your video, it just floored me.
really, like when they took the lid off and it's like, look, it's a television set in here.
There is a reason why I didn't spoil myself. I did not go into that box. I feel kind of bad at how dirty and dusty and disgusting it was, but I think it made a great, really fun video to watch.
You know,
the channel changers.
it's an interesting machine because like it's clearly some amount of, I mean, not to take away from Mike who made that thing, it's like there's a little bit of engineering work because, it was all trying to make it all jigsaw puzzle in there.
Yeah.
It's not easy. And like,
And you could follow it because of the removed cartridge connector.
Right.
Oh, he was thinking he was going to do something. Oh, but that wouldn't work. I got to get a bendy cable now.
and it's funny because I didn't talk about this in the video actually, but when I hot glued the speaker back in, I put it in a spot which I thought would be perfect. And then when I went to put the lid on, it actually hits the top of the disk drive cage. So like I had to melt the hot glue and move it because like those are the kinds of things, when you put the cover on a Model 3, you can't see how much space is around in there.
Yeah.
And you're hoping that when you put all the stuff back in there, that things aren't going to interfere with each other because you don't want, stuff touching other things. So it's not even easy. And I have to wonder like how long these folks who were making the repacks, they weren't following like a web page, or a YouTube video guide on doing it. This one, maybe there was something in a magazine or maybe Mike was just doing it from scratch.
There were articles, things like, well, how long can I make that extension cable before it causes problems, And so there were articles to read. There were some bits and pieces that you would buy that were professionally made, some keyboard extension cables
Right.
if you wanted to get your keyboard away from your CoCo.
Right.
And things like that.
Well, it's funny because, clearly everything inside here was 100% homemade. He didn't use anything off the shelf. And rewiring that keyboard from a Model 3 as the Model 3 keyboard, probably when it worked well, before, the dirt went inside the key switches and now doesn't work so well, that would have definitely been the best CoCo keyboard probably ever because it's an Alps SKCC mechanical keyboard. Those switches are amazing. That's what Apple used on the Mac Plus, for instance, and all those early Macs. And very, very good quality. It feels really nice to type on when it's clean, working properly.
One of my prized possessions is a Marty Goodman CoCo that has a Model 3 keyboard in a separate case with a long wire going back to the CoCo 3.
So it's like a custom enclosure for the case?
Yeah.
I mean, for the keyboard?
And so you could put the keyboard in your lap while you're CoCoing.
And you could still type on the regular CoCo keyboard too?
No, it's gone.
Oh, he took it out. So he just had like a blank plate there, basically?
A really nice airflow. Now that
Well, a
the
big gap
keyboard's-
was there?
Big hole, yeah.
I mean, it's funny. The CoCo run's quite cool, even that CoCo 1, except for the SAM chip. It gets really hot. I stuck a little heat sink on it, which people may have noticed in the video. It appeared at some point.
Bing.
Yeah. But okay. Well, tell me, so what kind of stuff are you working on now? Are you on social medias, YouTube, stuff like that? How can people find you if they want to follow you?
I have a personal YouTube channel where I post geeky stuff about the CoCo and electronic stuff and MAME tutorials and stuff like that. I have that's just Tim Lindner on YouTube. I have a channel where I play video games with my sister. It's a Let's Play channel called Sibling Rivalry.
Awesome.
And wearing a t-shirt. Buy
Shameless
our merch.
plug, yes.
Buy our merch. And besides that, I help people on the Discord community, answer questions. I try to help out as much as I can. Of course, I'm running a MAME code pretty much all the time.
That's awesome. I have asked you for many CoCo questions, and you always come through with the right answers. So I really appreciate that. I'm learning about CoCos. In fact, having met you, you've shown me that there's more to the CoCo than meets the eye. Let's just say people look down on the CoCo as a primitive machine, and it's got this green, horrible screen, and it's just lame. I mean, like
32 columns. That's what people show when they show it.
Right, and compared to a Commodore 64, which did come out later, the CoCo's older, it's been around longer. Compared to even its contemporaries, people are like, oh, they kind of look down on it. But the reality is the 6809 is by far the most powerful 8-bit processor ever made.
Well, Motorola wanted it to be considered almost a 16-bit processor.
Yeah.
And in the same way that their 68,000 chip was a 16 and 32-bit processor. There's a lot of untapped potential inside of a 6809.
Absolutely.
Definitely. And that's why we don't have any blitter chips or any sound chips in our CoCo, because we have a CPU that can handle that kind of stuff with the proper programming.
Yeah, with the right programming, exactly. Yeah. And like some of the games that are from like 1981 or 80 or 82 are pretty staggering. I have to say, I made a video years ago about the Spectrum Analyzer cartridge on the CoCo, which I don't know what year that came out in, like 80 or 81 or something like that, right? And it's honestly mind-blowing what that does in just 2K or 4K or whatever is a tiny little ROM.
Tiny little ROM. It has a hardware assist. I don't know if you want to talk about.
I don't think it does, because people have made a disk version that works, doesn't it?
There's a bit of hardware in the CoCo that makes that program possible.
Got it. Yes. Okay. But but my point is it's not like in the cartridge.
No, it's not doing fast for your.
There's no like lookup tables. Like people were like, if they saw that video, they were like, oh, there's got to be a chip in the cart that allows that to work. But
Some sort of analog to digital.
It's all in the CoCo.
It's all in the CoCo. The reason why that detector is in there is for reading tapes so as fast as it does. The color computer is a very, very fast tape system that is quite exceptional, and it's all because of that chip that can detect the zero crossing and the exact time that it happens.
Right, and then with that, it's able to actually pull out all the spectrum, because most other computers, it's so much more simple the way the tape circuit works, and it can't really detect all that wide range of frequencies. So I don't know, that really blew my mind as like an Apple II user back at the same time as the CoCo was out. I wished I could have something as cool as that. And then when I saw that, I was like, damn, this is cool.
Well, the first time you probably saw it was in Revenge of the Nerds.
I don't even think I realized at that time that it was coming from the CoCo. You know, he has the CoCo and it's on the TV.
Yeah.
I know that now, but then I probably would have just thought it was some movie magic or some, powerful computer in the background.
Oh yeah.
Not something.
Some Cray, doing real-time analysis.
Exactly. Not like a cheap computer from Radio Shack. It was a CoCo 2 in that movie, I think. I don't know what they cost at that point, but anyways, so some of the games and stuff that you showed me too that are original, like cartridge-based games, are really impressive, like really creative use of, let's be honest, there are quite a lot of limitations with the hardware. As powerful as some parts of it are, other parts are very limited, and they were able to do some pretty amazing stuff.
I think so.
Yeah.
And I always have fun firing up some of the old games.
Yeah, no, so that's really awesome. I appreciate you kind of showing me some of those new games, and I have to say, even the bad joystick I don't like with that Doubleback game, it's like perfect. That joystick works really well with it.
Yeah, it seems to have been made exactly for that game. And there's a couple other games that really accentuate the Black Beauty, as we call it.
The Black Beauty, yes. I'll put a picture of the joystick. It's just a regular looking joystick, but it has no spring back. So at first you're like, what is this?
And it's got circular input, so and most of them are square.
Yes, that's right. So. All right, well, Tim, thank you very much for coming on the channel. I really appreciate you talking about this stuff.
No problem. It's been fun. I'm really honered, actually.
Oh, well, now you're my first guest. I will put links down below, of course, for your channel and stuff like that. So if you want to check out his various channels or any other socials, it'll all be down in the description below.
Oh, thank you.
All right, well, thanks. Okay. And with that, this series is finally over. It's been a monumental amount of work getting this basket case of a computer working. Although I have to say, it's not as much work as it was on the TRS-80 Model 2. That machine was in similarly rough shape, although cosmetically wasn't as damaged as this, but it was a more complex machine inside, and of course was a lot harder to get fixed because of the obscure problem it had. Fixing CoCo 1s and CoCo 2s is pretty simple because they're very simple machines. I know some viewers are probably going to be disappointed that I don't do a full restore on this computer. I've talked about this on the channel before, but I much prefer to work on electronics. That's where my expertise is. The cosmetic work that would be required to bring this thing back to, well, showroom condition is a little bit beyond my ability and beyond what I really like to do. So I'm going to be passing this computer back to Tim so he can do, well, maybe he'll do a restore on his channel or give it to someone else who will. This will probably be the last time you're going to see this particular computer on the channel. But don't worry, I have more TRS-80 computers that will be coming up in the future for repairs and other such things. But in the meantime, I think it's time for me to focus on some other projects, and I'd like to get this space back on my bench. It's been sitting here for quite a while. So if you enjoyed seeing me work on and bring this old TRS-80 CoCo repack back to life, I would appreciate a thumbs up. But if you don't, you know what to do. Hit that subscribe button if you haven't already. It really helps me out. Second channel videos are interesting if you like watching me open up mail call items and do simple repairs. Plus, there's a bunch of CRT repair stuff over there. I want to thank my patrons. Their names are scrolling up the side of the screen as usual, and patrons get early access to videos and stuff like that. So you know, all the usual YouTube stuff. So that is going to be that. Stay healthy, stay safe, and I will see you next time. Bye-bye.